Okay, brief explanation of Rolle's theorem. Essentially, graphically, well, here's the theorem stated here, but graphically, I kind of lost my spot there. Okay, so here we are. Essentially, Rolle's theorem. F is continuous, closed interval, and differentiable on open interval. If f of a equals f of b, then there's at least one number c such that f prime of c equals 0. So what this means is this. If you have a graph, let me put it over here. Let's say you have a graph in here, and f of a, let's say, there's a, and here's b, and f of a equals f of b. So you see both points are the same height. Then if the f is continuous, closed interval, then there's one number c such that f prime of c equals 0. In other words, it's continuous, so it must do something like this and eventually come back to this point. That means the one that I've drawn, for example, has two places, actually three, 1, 2, 3 places where we have f prime of c equal to 0. So that's the idea. You have to have the continuity to be able to say this, and you have to have the differentiability to be able to say this. Otherwise, you might have a situation like this, where you have f of a, here's b, here's a. It's possible you could have a situation like this, comes up to a point and then back down like that, in which case there's no place where f prime of c equals 0. So the differentiability condition is needed, as well as the continuity condition. So let's see, let's do an example here. The term of the Rolle's theorem can be applied in this case if we can't find the values such that f prime c equals 0. So, well, we have a continuous function. Is it differentiable? Yes. Polynomials are continuous and differentiable. So those two conditions are met. Third, a and b. Calculate f of negative 1. Does that equal f of 3? That's our third condition. So let's see if that's true. We have f of negative 1 is a 0. F of 3 is a 0. So it is true. So that means that there's going to be a number between negative 1 and 3 where the derivative of f is actually equal to a 0. So let's find it. Let's find our derivative first of all. F prime is 1 times x plus 1 squared, and then plus an x minus 3 times a 2 times an x plus 1. That's the derivative of, that's the product rule in action there. Okay, setting to 0, I'm going to factor out an x plus 1. I'll have an x plus 1 plus 2 times x minus 3. Okay, working a little more, x plus 1. This would be 3x, and minus 6, so that'd be minus 5. So we have two places. One of them is a negative 1. That's not predicted by the theorem. But this other one over here, x is 5/3. That's the one that is predicted by Rolle's theorem. So we're all happy with that one. 5/3, 1 2/3. So it's in there. It's all good.